Hi everyone, welcome to the course. In this lecture, first I am telling you about unsupervised learning, clustering and dimensionality reduction. In dimensional reduction, the goal is not to look for distinct categories in the data. Instead, the idea is that the different fields are largely redundant and we want to extract the real underlying variability in the data. The data is that your data is three-dimensional, but all of the points actually only lie on a k-dimensional subset of the space plus some d-dimensional noise. For example, in 3D data, your point could lie mostly just along a single line or perhaps in a curved circle. Real situations, of course, are usually not so clean cut. It is more useful to think of k-dimensionals as capturing most of the variability in the data, and you can make k larger or smaller depending on how much of the information you want to reproduce. Now, the curse of dimensionality. Geometry is high dimensional space in word. This is important because a machine learning algorithm with d feature operates on feature vectors that live in d-dimensional space. D can be quite large if your feature are, say, all of the pixel values in an image. In the case, the performance of these algorithms often starts to break down, and this decay is best understood as a pathology of high dimensional geometry, the so called curse of dimensionality. Now, again, phases for dimensionality reduction. Script will dive right into a lot of materials that we cover. It loads in a sample data of images of 64 by 64 pixel faces with 10 pictures each of 40 different peoples. It then clusters the image, prints out a measures of how distinct the clusters are from each other, and then prints out a measure of how closely the identified clusters line up with the identities of the human pictures. Then the script uses a technique called principal component analysis to reduce the 4096 dimensional images down to a server 25 dimensions and reduce the analysis. Now, principal component analysis and factor analysis. The granddaddy of dimensionality reduction algorithm is, without question, principal component analysis of PCA. Geometrically, PCA assumes that your data in d-dimensional space is football shaped and ellipsoidal blob that is stretched out along some axis, narrow in order, and generally free of any massive others. Now, script loads and understanding dimensionality. In our motivation of PCA, we suggest that the dataset was ready one dimensional and that one of the goals of PCA is to extract that real dimensionality of a dataset by seeing how many components it took to capture most of the dataset structure. In reality, it is rarely the clear. What you get instead is that the first few components are the most important, and then there is gradually taper into uselessness as you go further out. And that's it for the lecture. Thank you for watching.